Right, we're live. So we're carrying on with the Voron build. Obviously we got a little bit stuck with the probe last time, so we have a solution for that now, and we're all good to progress forwards. Just want to get this stream in at a bit of a funny time, just to make sure we're still making some good progress, and we're on track for hopefully a final print at the end of this weekend. So, plan today is just to carry on through the instructions for the setup of the configuration. May not be a full 2 hours or anything like that. We'll see how we get on. But you should know that this stream is sponsored. This video would not have been possible without our sponsors, Filler Farm and Big Tree Tech, so a big thank you to them for supporting Vector 3D. You can find out more by just watching some more, or you can follow the links in the video description. Righty-ho, so probably going to be a little bit of a quieter stream today, hopefully nice and chill and relaxed and whatnot. It is a bit of an odd time, I know. I just wanted to try and make progress, because sometimes it feels like it doesn't, or I can't. So I have done lots of like pre-planning for all the rest of this firmware config stuff. There's been a bit of an ache, but hopefully we should be able to swim through it a little bit more easily. I have made some little changes to the machine that you may notice already. So the X and Y drag chains, previously I'd fitted them sort of the wrong way round. So on a drag chain you have two ends. Might be able to demonstrate with this one. Yeah, let me try and give you a half decent demonstration. So, oh, this is a really long chain now. Good morning, everyone. Great time for evening in Sydney. Ooh, Sydney time. That was that's a surprise. I wasn't expecting that. Well, good morning. Good morning, Sydney. So, to explain about fitting drag chains the wrong way around, there are generally two ends. One end will do this and rotate all the way around like so, and the other end will be fixed like to the rotation of the other. Come on, let's get a bit closer. Kind of fixed to the rotation of the other end. So this one can't pivot up or down, which means it has the advantage that when you fix it to a particular direction, like so, this chain can't then come up above that point. So on the Voron, where you have these chains, come on, these chains being fixed one end, you don't want this to kind of you don't want it to like rise up and do a big curve like this, like that or anything. You want it to stay flat, so you're just doing this kind of this single roller motion like this, and none of this big like curvy, weird, annoying, like, because it just bends the cable wrong. The whole point is that it rolls in one place. Well, it doesn't roll in one place. It rolls consistently like this, so it bends all of the cable evenly across its whole length. Good evening, good morning everyone, to people in all sorts of different places. It's nice to have some different people here. Not that there's anything wrong with the normal people, but just nice to do things different time, I guess. So yes, I've fitted them now the other way around, so that part that doesn't rotate is now at this end, so this chain can't pop up and do weird things. So that should stay a little bit lower, a little bit more securely. Did have to like reconfigure the whole lot just to get some tiny little bit more cable length in order to do that. But I think we've just about made it. So that took a little while. But we're back and we can carry on. So at the end of the last episode, we had a problem with the probe. And the next morning I spent, it literally took me 10, 15 minutes maybe to diagnose it and sort it out. Basically, well, the full explanation is on the, is a pinned comment on the last video. So if you're interested or having the same problem, I suggest you go and check there. That will be the best place to have the most information. But basically, a combination of using the PCB, having an NPN probe, and the optocoupler on the Big Tree Tech control board. Those three factors combined meant that the way I was putting the signal into the board was not going to work without an additional resistor that I didn't have. So the easiest way to solve that was not to buy a resistor, because that would have taken time and money. I could just move it to an adjacent port and reconfigure the pins in the firmware. Very easy to do and costs no money. So that's what I've done. It's now on an adjacent port. So there you go. That's how that was sorted. Hopefully now we can basically carry on with where we are. People being able to join live for the first time. I'm glad to see it. Welcome to the live streams, where chaos is always just around the corner. So yes, let's carry on with hopefully where we were. I've also updated Klipper and changed the screen to blue. That's not really a major change. Let's put a bit of face cam on this one. Okay. Perth, Australia. Is everyone here from Australia today then? Is it very much an Australian-based live stream? An accidental Australia stream? So hopefully I can show that the probe works. So let's start by homing all. I think that's going to be okay. It's always a bit suspect now. I'm like, now things have happened. Just getting used to it. Because it has this tiny little probe thing at the back, I'm always super worried about it hitting something. It's all on, I think. Yeah. So it should be able to just go. USA and Canada. So is it very early morning there? What times have I hit people at? What have I done? So if we move this to the middle of the bedish, and we'll move it up a touch. So with ruler, we should, if we query probe, which basically just tells us what the probe's doing, we get probe open. And I've realized today you can click the commands in here and it sends them back to here. That's good, isn't it? So if I now stick the ruler under here, bosh, send it again, triggered. I can also see the light from this angle, which I hadn't noticed previously, so that's pretty good as well. 7:26 p.m. in Sydney, 4:30 in Perth, and 4:26 a.m. in Canada. Blimey, that's early in Canada. 3:26 a.m. on the 13th. Okay, so very early morning. Very early morning USA, and afternoon or evening Sydney, Perth, Australia. 9:30 p.m. in New Zealand. Oh, so New Zealand is exactly 12 hours different, because it's 9:30 a.m. here. Well, it's good to have everyone from all over the world. Welcome. So yes, probe is now working, very happy with that. Did take a little bit of reconfiguring, but it is now sorted. So good, 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 good. Once we've got that sorted, slowly reduce your Z height, run query probe until it turns trigger. Make sure the nozzle's not touching the print surface and has clearance. Okay, so we can move this. If we move it back to 5, that's where it probed. And then go down from there. Okay, it's going to allow minus. So there you go, that's triggered, and the nozzle is not touching. There's definitely gap still under the nozzle. Not that much gap. It's just, well, the ruler I think is like 1.6 something mil thick, and it's just hitting it, so maybe it's a mil a bit. I think that's pretty good. Perfect streaming time. This is live. This is absolutely live. Blank. This is live. This is not pre-recorded. I wouldn't cheat you like that. So we can move on to a probe accuracy check with the run. With the bed and hot end cold, which we do have. Move the probe to the center of the bed, which we've done, and run probe accuracy. It'll probe the bed 10 times in a row and output a standard deviation value at the end. Make sure that the sensed distance is not trending, which is gradually increasing or decreasing over the 10 probes, and that the standard deviation is less than 0.003 millimeters. That is bonkers. Okay. Example of unstable probe accuracy shown below. Okay, so stick that in there. Oh, you can't actually see that part of the screen. There you go, because that head is in the way. So stick that there. So run probe accuracy, and we should, I guess this is going to do some probing stuff. We send that. I might just move it up a bit first, just in case. Send it. It's doing the jiggery. Oh, that was pretty good. Standard deviation 0.002550. Well, that's less than 0.03, so we're good. That's very nice. Maximum minus 1.47, minimum minus 1.48, range 0.01, average 1.43500, median and standard deviation. Sorry. I don't know where that sneeze came from. That came out of nowhere. I panicked and was like, I need a mute button. Sorry for those that are wearing headphones or something. That is very, very small deviation. Now I have to pretend to work and watch a stream. Yeah, sorry about that. I mean, it's a daytime stream for the UK, I guess. Morning stream. And then we got USA very early morning, and Canada and Australia coming in and covering up the evening slot. So we've got all times of day. I am really... hang on, I'll be 2 seconds. Okay, I'm back. 10:30 AM in Spain. There's a whole new collection of people. So excited. So we can now do PID tune for the bed and the hot end. So how does it suggest we do such a thing? PID tune is important for tuning the printer for a given hardware configuration to ensure that the temperatures can remain stable. Yes, I know this. PID tune the heated bed. Move the nozzle to the center of the bed, which we've got 5 to 10 millimeters. Let's make it like 8 then. So that's a big 8, but sure. And run PID calibrate heater equals heated bed, target equals 100. Paste this plain text. Send it. Fans have come on. Oh, I can feel them blowing out of this side. Blimey. That's pretty good. I didn't expect that kind of airflow. That's nice. Do I put the part fan at 100%? It doesn't say to do anything with the part fan. For the part, so here, it looks like on the next one, for tuning the hot end, it says put the part cooling fan at 25%. Polymate's here, good afternoon. I mean, good morning. Even I have no idea what time it is. It's so confusing. You're welcome for the early stream. Still not quite as busy as the normal one. The last Klipper one we did was actually like 106 people, which was rather impressive. I think it's the first time actually that one of my streams has gone over 100 and something people without having like a raid from another stream. So that was pretty good. I might be wrong, but 37 people today, so we're a little bit lower, but still very nice to see. And it looks like we're going to be getting some more people because numbers are increasing. Everyone's just obviously a bit confused and they like, has he accidentally put a stream for 9 o'clock in the morning? Surely he kind of done that deliberately. So we're doing PID tune, and this is obviously just going to go up to that line and then go up and down a bit just to kind of check what the temperature. Looks like power we limited to 80%, so that leaves us how much power? 480 watts. Oh, why do I seem to have a allergy or cold or something? Got a snotty nose. It's not good, is it? Maybe it's from sniffing too much ABS. Despite me having the settings on the lowest latency, it still seems to be quite a few seconds before everything gets to you and back. +1 for more daytime streams. We'll see what I can do. I mean, I do quite enjoy streaming, to be honest. I kind of debated trying to do like a lot, but it needs kind of sponsorship, and that's the really difficult thing to sort out, because if I can't get paid for it, obviously this would normally be working time for me, so I'm not getting paid normal working hours. But I agree, it would be quite fun to do. Oh, Big Tech Octopus is a great choice for Voron build. That's what I'm using. I am sponsored by them, but it's still a pretty good choice. You'll probably be interested in my configuration file, which I'll share when I've got all this stuff sorted. This is taking a little while to heat up, isn't it? I guess gradual means we're not going to be bending or warping the bed at all, which I suppose is a good thing. Just makes the whole thing a little bit slower. Did I get a CR30? You're asking me? For the config file. I haven't shared it yet, but thank you very much for the $5. It's very kind of you. I'll put myself a reminder to make sure I do share it. That's definitely the intention. Sound cutting in and out. Anyone else got sound problems? I'm sniffing. It's going to be annoying if I'm sniffing all the way through this video, isn't it? Back in a second. What Pi are you using? I'm using a... It's a Raspberry Pi... I've got a spare one here. This is the 8 gig version. So Pi 4 Model B. So I'm pretty sure the latest, most expensive one. This is an 8 gig model, but as far as I know, I've not tested. 3B is like a good one to go for. It's powerful enough easily and much easier to get hold of, especially in the UK at the moment. The stock is very low, so prices are through the roof. I've heard you can also go with a Raspberry Pi Zero if you don't have a webcam, apparently. So by all means, give that a go. I might at some point, just to compare, just to see what you do need. That might be a cool little video. Why am I getting some funky smell? It's just, I think it's like new smell. Hopefully it's not a bad smell. Don't think it's a melty plastic smell. That all seems to not be melty. The aroma of the glue. Could be, could be. Any Pi with more than one core can run Klipper and a webcam. A Zero can keep up on some setups without a cam. If you push speeds, you may get shutdowns due to time between MCU and Pi. Yeah, so I was talking specifically 2.4 because obviously it's Core XY. There is a little bit more calculation than your standard Cartesian, like XY standard setup. I know this is like, I don't like it when people say normal printers are Cartesian because they're all Cartesian unless they're polar coordinates. Cartesian just means like X, Y, Z perpendicular axes. Anyway, God, this does smell. There's a real funky smell. I'm a little bit. Is that what slicer do I plan to use? I will be probably using Prusa Slicer because I use it a lot. And I'm pretty sure there are pre-configured profiles for it. So that makes the whole thing a little bit easier. Did you try Super Slicer? I have at one point given it a go off camera, unrecorded kind of thing. It just, yeah, not used it like in anger, I suppose. Maybe we'll give Super Slicer a go then. as it's got a lot of stuff built in. Not that super slicer. They've got releases on here too. Pre-release, let's not go pre-release. I at least want a release version. Oh, that looks like PID for the bed is finished. What are we doing now? It'll perform PID calibration routine. Once it is finished, type save config. You can actually, again, because this is in your Kali, because you've got this blue text, that means you can click it and it sends it straight to here, which is super convenient. So to do that, and that will save the PID parameters, which are this bit here. I have never really got on that well with Cura. I find the user interface really irritating. So I just generally avoid it unless it's absolutely necessary or comes with a printer and it's expected that you use it for the first print and that kind of stuff. Generally I use Prusa Slicer at the moment. It's my go-to. Obviously Super Slicer is kind of a modified version of Prusa Slicer / Slick 3R. But so next we'll do a PID tune for the hot end. So set the part cooling fan to 25%. Part fan, oh, we can just stick a number in here. Boom. Cool. And then run M1S, oh no, that's the fan, and then run this. Perform a PID calibration routine that will last about 5 minutes. Once it's finished, type save config. So this is just going to be another send it and leave it. So it's adjusted the graph to go up to 250 so we can plot the 245 temperatures. We'll probably stretch a little bit more once we get up there as well, I guess. Anyone remember Simplify 3D? It's not that old. I never actually used Simplify 3D. When it was popular, it was always too expensive. And now that it's not popular, it's still too expensive. And just not worth having, when you've got so many good options that cost nothing. While we're here, can we scroll ahead? Bed leveling, we're going to need to wait for it to cool down. We're going to need to wait for it. So I will be doing input shaping. So for that, I've got this. I'm just going to leave that to do that thing for a minute. It's going to take a little while, and I'm sure you know what PID tuning looks like. So this is an ADXL 345. It's basically a little accelerometer on a PCB that allows you to measure acceleration. So I can use this to do automatic input shaping, which will give me like nice graphs and decide for me all the profiles to use to do input shaping for this specific printer. There's a whole bunch of different ways you can mount it. I mean, some people have tried taping and blue tack and stuff. It's suggested that you screw it down to something. You can use the screw holes that are like already built into the hot end and just kind of squish it against it. And then people quite often try to make the back flat, which is not that easy to do. And that way it keeps your principal axes, your X, Y, and Z in line with where they should be. It doesn't matter if like Y is X and Z is Y or whatever, as long as they're pointing in those principal directions, then you're okay. I was not particularly happy with doing it just like a random way. I wanted to get a decent mount for it. So I made this, which if we look over here, you might notice where it will mount. Is it going to struggle to focus because of the reflectiveness? So this will mount directly onto this bit here. So it's right down low by the hot end. Ideally, like, I want it right next to the hot end, but this is, I think, is going to be definitely good enough. It's probably a bit far from the hot end in terms of the distance from the rail. Oh, why is the camera struggling so much with this? Okay. Yeah, so ideally it will want to be even closer still, but I think this is going to be pretty good. And the way I've designed it means that not only do you not have to worry about the pins on the back, you can just solder them in like normal, because they, if you look here, oh no, it's not going to focus. Come on, please. So it overhangs the edge when mounted in those holes, so you don't have to worry about how they're set up. And it also keeps all the axes in their intended orientation, so X is X, Y is Y, and Z is Z. So it'd be very easy to get confused if they were not in the intended directions. It's not that complicated, but it's easier to save yourself a mistake and just put them in the orientations that they're meant to be in. Yeah, everyone hit the like button, let's do that. 10 likes for 50 people. That's honestly more than I was expecting for this time of day. But obviously my time of day is not everyone else's time of day, which I neglected to think about. Well, I didn't completely, I didn't expect people to want to watch a stream unless it was like a normal schedule, but there you go. Obviously people do. So we can mount this to this with two M3 by 6mm screws. You could use slightly longer ones. I've not done any fancy holes. They're just like 2.85mm. So you should be able to just screw straight into them with an M3 screw. It doesn't need to be exceptionally tight. It will need to be quite tight though, because you are going to be vibrating the printer a lot with this installed, so you don't want it to move. And I might change the design a bit because I think I've cracked it a little bit there, so this bit should probably be a smidge wider to make sure that doesn't happen. Let's go and do that now, if we're still waiting for the PID tune, I think. Oh no, that's actually just finished. So yeah, that little board will secure on here quite nicely, and I've also made a cable. We'll get to that when we need to. For here, obviously, same as before, we can just hit save config and it'll take those PID parameters and chuck them in the configuration file and restart the printer. If you're having trouble printing parts, you can use print it forward. I did the same thing. Not for the same reason, but I did do the same thing. You can say print it forward, we'll print the parts for you. You just have to pay for all the parts. It is fairly expensive, but not that expensive when you consider how many parts there are. It's much cheaper than going to like a printing bureau or something. Can you hear the fans? Those are the 60mm fans that are doing the enclosure underneath. They are quite loud. I might turn their max power down a little bit, but at the same time, it's nice to keep everything cool. And it's not, while it is reasonably loud, it's not one of those really annoying fan noises. Like it doesn't sound bad, it's just definitely audible. So, oh, we're on the wrong screen, so you wouldn't have seen all that stuff I was doing. So we did the save config and that all restarted. You can see the PID parameters that it came up with. Obviously, don't just copy mine. You need to run this yourself if you're following along. Bed leveling. Depending on the printer type and capability, the following commands are used. So, obviously different ones. For V2 here, I'm going to be using quad gantry level. So let's find that. Since the V2 uses 4 independent Z motors, the entire gantry system must be specially leveled. The macro to call this is quad gantry level, sometimes referred to in conversation as QGL. It will probe each of the 4 points 3 times, average the readings, then make adjustments until the gantry is level. If the process fails due to out of bounds error, disable your stepper motors and slowly move your gantry or bed by hand until it is approximately flat. Rehome your printer, then rerun the sequence. You may have to run it more than once. Make sure that the adjustment value for each stepper motor converges to 0. If it diverges, check to make sure you have your stepper motors wired to the correct stepper driver. Right, that's a lot, isn't it? So, spoilers, I have actually run this a little bit already, and I shimmed my bed all up 1mm because it was too far down. Or was that related to something else? That might have been related to something else. Anyway, I've done that, just FYI. So, quad gantry level, if we copy this, I think now, lots of copy paste, and then I think actually there's a button in here, isn't there? I thought there was a button in here at some point. Is it only when it's wider? There you go, there's one for QGL. Oh, you have to have it first. So let's home all. Oh, I don't know why I'm so snotty, I do apologise. Hopefully it doesn't come through too badly over. I'm trying not to sniffle too much. That's the Proby boy done. So let's run quad gantry level. Do, 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 do. Go. So you can see that it's bringing up all those values. That was very good, they were all like identical. First one's slightly different there, there seems to be some variation there. The tolerance that it's searching for is extremely fine, so I'm not surprised if it misses it sometimes. So you can see that it did a probing round, it's made some adjustments to the Z direction, to the Z motors to change them a little bit. Now it's going to go around again, just to verify, I think, basically. Quad gantry leveling is a little bit weird because, as you're probably aware, why is it going back to this one? You only need 3 points for a plane, but you know, this thing is thing. What do you think about E3D's new nozzle? It seemed to me that it would break very quickly. There seems to be no support equipment at all. What? What do you mean support equipment? Well, it's not released yet. I've not used or seen, well, I've not used one, of course I've seen them, I made videos about. I think it's promising, and I don't think it's going to break easily. So, odd question. So I think that's done a thing. It's made some very small adjustments, and then it thinks everything is okay. Cool. Right, well that was quite easy. Oh goodness me. Hang on a second. Okie dokie. The mute really highlights how loud the fans were. I'm surprised the mic picks them up that much, to be honest, because normally this mic's really good at just capturing my voice, not too much else, but obviously I have to have it quite sensitive, because I talk quite quietly when I'm doing live streams compared to making videos, weirdly, but there you go. Anyway. Tilt or QGL with heated bed. So the probe is stabilised with the heated bed at 100C, hot at 240. Run probe back to the nozzle at the centre of the bed if the values are trending. Once the readings are run the Z to adjust or quad country level. Make a note of how long the probe readings took to stabilise for when starting prints. Typically a cold printer takes 10 to 20 minutes to stabilise at temperature, so you want to heat it for 20 minutes, that's quite a while. I'm not going to do that, I don't think, at the moment. It doesn't seem to make a difference to what settings you do. Mesh bed only for switch wire, Z offset adjustment. Up to 54 people. Oh, by the way, don't forget to like, I think we mentioned that already. We should do a quick sponsor segment right about now. This live stream would not have been possible without our sponsors, Firmware and Big Tree Tech. Firmware are a 3D printing bed specialist based in Germany. Print is their high-performance, durable print surface designed to grip parts tightly when hot, but release them when cold. Their switch system utilises a strong magnetic sticker and 0.6mm spring steel to allow for easy swapping of bed surfaces. The bed plates offered are made from cast aluminium plate and are extremely flat, helping you get the best adhesion across the whole first layer. All of this can be made to standard sizes or customised upon request. Keep on watching to find out more, or follow the links in the video description. The Big Tree Tech Octopus is a 32-bit control board with loads of connectivity options for performance 3D printers like the Voron 2.4 and RapRig VCore 3. It can connect up to 8 stepper drivers, 8 fans, 6 end stops, 5 thermistors, 4 heaters plus BL Touch, RGB LEDs, a TFT screen, USB-C and more. Pairing the Octopus with TMC 2209 stepper motor drivers allows for quiet operation using Stealth Chop, performance using Spread Cycle and Stool Guard for sensorless homing. Big Tree Tech also offer a mini 12864 display, which is ideal for the Voron 2.4 design. Check the links in the description to find out more. I'm just having a look at the settings for fans. I'm going to try putting these in at a reduced maximum power for controller fan 2 and controller fan, and then they should be a little bit quieter, but that may use PWM and then they may be louder because PWM whine. Oh, I need another value. Oh, why did it make me do it for this one and not for this one? Config reference, look up max power. Maximum power expresses value from 0 to 1. Heater pin may be set to. The value 1 allows the pin to be set fully enabled. Value of 0.5 will allow the pin to be enabled for no more than half the time. This setting may be used to limit the total power output over extended periods to the heater or fan, I guess. Generic fans may be used to limit total power to fan. If the value is less than 1, fan speed request will be scaled between 0 and max power. For example, if max power is 0.9 and fan speed of 80% is requested, then fan will be set to 72%. The default is 1.0. What did it ask for? Shutdown value. Shutdown speed. We want 0, I think. The desired fan speed if the microcontroller software enters an error state. I think we actually probably want 1 to keep the controller and everything cool in the event that some weirdness starts happening. Oh, okay, well, this has turned out to be more complicated than I had initially considered. So let's just forget about it for now. There we go, cool. And they're back. So, Z offset adjustment. If you did not run PID tuning, set your extruder to 2.4 and heat the bed to 100C and let the printer heat up for at least 15 minutes. But I did run PID tuning, so I'm going to not do that. Huh? Okay, I'm going to not do that. Preparation. Run G28. Let's just table. And then quad gantry level, and then another G28. That's G28, so let's run quad gantry level. Send it. And then another G28. Looks like some weird damage to the belts. They look really mangled. What on earth happened there? I'll have to keep an eye on that in the long term. That doesn't look particularly healthy. The belts are definitely a little bit on the tight side, and we will reduce them a little bit. Almost still. This one's definitely loose now. Let's just run G28 again. It is an early stream today. This is not a normal live streaming time. I wanted to get all this calibration-y setup stuff out of the way. So, G28, then quadrilateral level, then another G28. All others run G28. Move the nozzle to the centre of the bed if not already. This firmware is kind of annoying. When it's busy, it just doesn't run properly. 150, 150. Clear any stored bed meshes. I don't think I have a bed mesh. Nope. Run Z and stop calibrate. Slowly move the nozzle towards the bed using Z test -1 until the nozzle is relatively close to the bed. This is where I'm going to need a print surface, isn't it? That is still stonking hot. Maybe I won't attach it yet, but we're going to need one to get the thickness and stuff right. So this is the filler farm print surface. Obviously intended to be stuck on. Hopefully that's obvious, but I'm not going to be doing it at the moment because it's very, very hot. So we'll just put that there, and we're going to need a piece of paper. So we run Z and stop calibrate. Oh. Starting manual Z probe. Use test Z to adjust position. So Z -1 until we get a bit closer. So post the plain text and send that. So that's going to go down a bit. Can we just okay, just use the same again. 2, 3, 4, 5. That's getting pretty close. And then stepping down with Z -0.1. More 0.1 in there. That went up. Where did it go up? That's no good. What? It went up and then comes back down. That's not the whole. This is totally wrong. I'm assuming it's not going more down than up, is it? I'm not sure it's going down at all now. No, maybe it is. There we go. And here, nozzle touches a piece of paper. If you go far down, you can move the nozzle back up. Once you're satisfied, run accept. Oh, not like that. And then save config. Nice. Okie dokie. Don't know why there's a big gap in here. 0.4. I think the bed is quite hot, so there's only 43, I suppose. Klipper assumes the process is being done cold. Well, it's reasonably cold. If performed hot, do an additional minus 0.1 before accepting. It's a bit late for that now. Hopefully it's going to be okay. Fine tuning Z. Z offset can be adjusted during a print. Okay, we're not printing yet. With and without screen. Saving. Extruder calibration. Now this is something I'm familiar with. Let's go home again. And I'm going to take the print surface off. We should get that connected at some point. Oops, a daisy. The lag you're experiencing isn't the firmware, by the way. It's kind of strange to see you never had the issue. It might be network issue with streaming or some kind of PI error. Well, so to be clear, if you watch, what I'm seeing is when, well, it definitely lags when it's in console, but here it's just because it takes the time when busy, and I can't edit it until it says ready again. I think that's the problem. Anyway, let's before the first print, make sure the extruder extrudes the correct amount of material. With the hot end at temperature, make a mark between your roll of filament and your extruder, between 120 and 150. An octoprint, extrude 50 two times, measure the distance, update rotation distance. Okay, this should be easy enough. Yeah, I guess, I mean, it's not an issue I've had with Duet Web Control, that's why I'm mentioning it. But I guess you can't type in numbers with Duet Web Control, I think, as well. You just use these, so maybe that's why it's... I don't know. It's not really a big deal. Once I get through this main configuration stage, I'm unlikely to be using that much anymore. It's just going to be printing the whole time. What am I doing? E-steps. So I'm just using some end of roll filament because it doesn't really matter. I do actually find it a little bit more difficult to do this when your filament is really curly like this, just because it's more difficult to measure. So I'm just going to try and straighten out a little bit. It seems dumb, but it does help a little bit with getting a decent measurement. In the meantime, let's heat up the extruder hot end. That's weird, actually. It does say the thermals is listed as extruder. I'd rather it be listed as hot end. Presumably that's just a name thing and we can change that. So. It was so the best answer for that question, Axel, is to go to the that last stream, number 10, I've written a little piece in there about all the different factors that impacted it. I wouldn't say it was in the wrong port, because it wasn't, but you can solve it by using that diag port or any other pin. Okay, filament's a little bit straighter now, so hopefully that'll work a little bit nicer. Don't know if square end or round end or pointy end is going to be easier. I think we can just grab this up. Nice. And poke this down. We're in. Nice. At this point, where's my calibration tube? There it is. I'm sure most people don't have one of these. This is a calibration tube. It's just a tube, but it's exactly 150 millimeters long. So it makes it much easier for doing this. Well, I wouldn't say much easier, but at one point I was doing it loads and loads and loads and loads, and it was an absolute pain to use a ruler the whole time. So this is just exactly 150 millimeters long, so I rest it on the top of the rest it on the top here, not down in the hole. You want to rest it on the side because that's where you're going to measure with the ruler, and then just cut the top flush with the metal tube. And that's exactly 150 millimeters. If you haven't noticed by now, I love my gauges and jigs. Anything that prevents you having to use measuring equipment is well worth having. And my top-down camera is going all over the place, isn't it? Let's sort that out. Oh, it seems to be okay now. Work smarter, not harder. Exactly. I'm all about that. So now we come in here. We'll extrude 50 millimeters. I guess it won't let you do 100. No. Too big. I'm also going to go slower as well. We don't want to have any weird limit issues. Why has it gone to 250? That's way too hot. 215. 215, please. 250 for PLA, you mental. In UK, it's 10:22. Time zones, eh? What are we doing? Yes, extruding. So I guess we now just press the thing. Temperature should be fine. Let's just go for it. 50 millimeters. It doesn't matter that it takes a while for the filament to come out. We're not measuring what's coming out. So even if your filament is just mostly traveling in here, doesn't matter. All that matters is that it's engaged with the gears before you start. So we'll do that twice and then give it a measure. It is a bit loud. It's probably on spread cycle rather than stealth chop. So here we've got 51 to 52.5 millimeters. 52.5 millimeters. So 150 minus that gives you 97.5 millimeters. So 97.5% basically. So the new value is the old value times the actual extruded amount, 97, over the target extruded amount. So you just multiply it by the decimal. So let's go into here, edit the config. Here. So we bring up a calculator. We want, oh, why is it weird decimal number? What a bizarre number. 22.67895511 times by 0.975, which is 97.5%. 22.1119773225. Well, I don't think anything beyond 1 or 2 decimal places is relevant. So let's call it 22.11. Save and restart. Let's take the filament out. Keep that open, feed this in. So I'm just doing it again just to kind of validate. And so I get to use my calibrated tube. So back to here, set temperature back to 215, extrude length back to 50, speed back to 3, wait for the temperature to come back, and then we'll go on another go. This is Hart's design, yeah. It is the Doom board. Okay, extruder's round 215, that would be good enough for this. 50 millimeters, go. That's one. Second one. Nice. And now we measure, and hopefully we get exactly bang on 50 millimeters. Yep, bang on 50 millimeters. Super happy with that. Done that before. Right, that's that. Next, slicer setup. Is there memory locks for different temps and material types for this setting? Shall I sell calibrated tubes? Should that be a thing? CNC's got his, Stefan from CNC Kitchen's got his threaded inserts. Maybe I should sell calibrated tubes. It's just a 150 millimeter tube. It's so useful. Measuring these things, especially when it's long, When it's 50mm, it's not too bad because you can you have enough fingers to kind of hold that. Well, luckily I do. But when it's shorter, it's much more difficult. I'd quite like a more advanced version. So you have your 150mm and then it has maybe a cutout here with a mark that shows you exactly where 50mm is. So you can just use the same tube. You kind of almost leave it on there, right? You leave it on, cut it at the top, let it do its pull all the way down, and then you can check exactly where it comes to. That, I think, would be fantastic. Apart from if it had, the problem with a hole is your filament might end up starting to come out of it if it's too bendy. Extruder calibrating tube. It sounds kind of dumb, doesn't it? But yeah, you've got to start somewhere. Products don't have to be complicated to be good. In fact, the simple ones are often, nearly always, the best. And I think what's important with this is getting the length exactly right. The precision of the length is quite important. So, and because of the material, choosing the right material helps because it stops it corroding or anything like that. Use a glass straw. Now you're you're asking for trouble. What happens if you do this? Yeah, you don't have a glass straw anymore. I mean, it'd be cool, yeah. But I think the problem with glass is you end up with weird refractive index stuff as well. It probably wouldn't be too bad, but anywho. All modern mainstream slicers are able to produce high quality prints when properly configured. The Voron community maintains a set of slice profiles that you can use. Proper understanding of slicer settings will have a tremendous impact on print results. Try to learn more about your favourite slicer and tweak the settings to meet your needs. While using different slicers for different kinds of prints can be beneficial, avoid blindly hopping between slicers and slicer profiles just because someone posted a nice print sliced with a different slicer. There are two slicers that come with the built-in profiles for most Voron printers, Cura and Super Slicer. Other slicers that can be configured to support Voron printers but do not have built-in support include Prusa Slicer, Simplify 3D and Select 3R. Some slicers, like Prusa Slicer, do not recognise the Klipper print start macro as a valid start macro and add an additional bed heat and nozzle heat to the start G-code. If examination of the output G-code shows an M109 or M190 before print start macro, consider using a different or newer slicer that recognises that macro as a valid start macro. Well, we'll use, It's not going to be print time, no. We'll get it set up, but I'm not going to be doing the print now. What we will probably do though, we'll do a input shaping tune. And we'll get the Super Slicer set up to make sure it's going to do the thing we want it to do. So let's install the Super Slicer. Stream might go a bit funny while I extract Super Slicer, hopefully not. Starting now. So, this is Super Slicer, apparently. Oh yeah, I did try it with the Rat Rig V-Core 3. So, presumably we can configuration wizard it. Right, we'll remove current profiles. So apparently there's Voron profiles. Oh no, this is just any qubit. Artillery, Bebo, Custom, Creality, INAT, who the dickens is that? Lulzbot, Prusa, SLA, Trilab, Vertex, Voron, here we go. Goodness me, what a lot of options. Okay. So we're 300, 0.4 nozzle, 0.6 nozzle, 0.8, and then we'll do a volcano. Why is there no volcano 0.4? Huh? Oh, Mobius is a different extruder. And V0. I kind of want a V0. Anyway, don't want a custom one. KVP. What the hell is KVP? I presume it's a brand. Updates. Check for application updates. Ooh, funky. Very nice. So oh, they took percentage off. Why are there no percentage? That's weird. Why are they really odd numbers as well? 4, 5.5, 7.5, 10, 13, 18. Strange. Okay. Afterburner 0.4 nozzle, basic PLA. 0.05, that's bononkers. 0.2. Do I have... We're not going to print this now, by the way. I think I already said. Oh, that slicing takes a while. Ooh, hello. That's gone weird. All right, we're there. Basically solid. What's the white? Gap fill. Sure. Why has it got gap fill on the inside of a print? Gap fill here makes sense because it's filling a gap between the two walls. But why is it gap filling here? It's just adding another wall. Okay, well, we don't need to worry about that at the moment. That looks good. That looks like it's all just going to export absolutely fine. Is there a way to export it directly to Voron? G-code, Klipper, support styles, precision, cooling, thumbnail, advanced, print host, all parameters from this group are moved to the physical printer settings. Physical. Klipper 192.168.1.123. Connection to Klipper works correctly. Yeah, boy! Oh, do I have to... I'm not very great with creative names. Let's just call it Voron 2.4 300. Cool beans. Is that it? Why is there no... I guess because Klipper adds its own start G-code thing, doesn't it? So you don't have to put it in a slicer. Which makes sense. 100% shrinkage. I guess we could calibrate that over time. Cool. Okay, I think we're good with this for now. We don't need to worry about that. Oh, I don't want to save the object. Okay. Cool. Right, let's do a different thing then. Oh no, what is there anything more we need to do here? For maximum quality and accuracy, preheating the printer is recommended. This can be part of a scripted process or separate. Preheat of at least 10 minutes is recommended in order to bring all components to thermal expansion equilibrium. This time may vary depending on factors. In testing, 350 V2 grew 0.2mm height after heating up for an hour. Every printer is going to have a start sequence that typically involves homing and or leveling to prepare the printer. This is in addition to heating the nozzle and bed and doing other tasks. Look at print start macro in the printer CFG for standard process. So I'm guessing we're going to have our print start. Okay, I'm assuming that whatever's in there is okay. You still need to set up your slicer to call print start and end. Is that not part of what I just... So why is it, I mean print end seems to be here. And print start is here. That looks fine to me. And then it's going to wait for all these things before it does this. I'm guessing that's how that works. It's a Voron flipping profile. I'd be amazed if it wasn't in there. So, let's do some ADXL input shaping goodness, eh? That sounds like fun. Let's cool that down. So, to do the ADXL business, I've made this cable. So the ideal scenario is an 8-pin, so 2x4 on one end, and an 8-pin which is 1x8 on the other end. I didn't have exactly what I needed to do that, so I've got two 1x4s on one end and another two 1x4s on the other end. It's a little bit messy, but it should work okay. So it looks a little bit like this. Well, it looks exactly like this. This is what it looks like. Please focus on this. So there you can see that one I've just kind of taped together. It looks a bit naff, but should work okay. Could probably try and glue them and whatnot, but I thought if I glue them and they end up not quite aligned, then that's going to be even worse. So spoilers, I have actually sort of done this already. So I do know it works. But we're going to go, the trouble is, it's one of those processes that once you've done it, you can't really undo it. So there's a bunch of extra setup that you have to do. I can walk through it now, but I won't be actually doing it because I've already done it, regrettably. It was quite difficult, so I can understand. Well, it was it's quite involved, let me say that. We'll run through just what codes you've got to use and how you can input them to your into your Raspberry Pi, but we won't actually go through it in detail. So, part one is obviously making the wiring. I've got this board on the right here, so we need to, now I've made this wire, I need to make sure I plug it into the correct place, which is very important to get right, because otherwise you're going to really royally mess something up. What temperatures are we at? 126. Let's take filament out. There we go. It's a nice little cold pull. So we'll get it back up in no time. So turn that off. I probably should shut down properly, but I haven't. Then we're going to tilt the machine backwards. This is much more difficult to do on camera. Keep it facing the right way. So what we're looking for is the Raspberry Pi, which is down here. So we're counting the pins. We've got 1, 2, 3, 4, 5, 6, 7, 8 pins. So 2 by 8 of nothing, and then the 2 by 4. And we've got to make sure that that VCC pin is in the top left of that bunch. So for mine, I've made sure that I have one red pin. That's my VCC, so that's my voltage, 24 volt, no, 24, blooming hell. That's the voltage pin that's going to be powering the ADXL. So that's the one that's going to help me indicate which way up this connector is going to go. Everything else is just black wires. And then we've got to very carefully count them. So 1, 2, 3, 4, 5, 6, 7, 8 pin. And then push that on, and that's all in place. So that should be good. And then, due to this lovely hex patterning in the skirts, we can just shove that wire out the side. It's not going to be permanent. We only need this to do the tuning. So it's a temporary install while we actually run the process. And then when we're done, we can unplug it and put it all back to normal. So I showed you this board earlier on in the stream. This is the ADXL board with this little adapter that I've made. I think I forgot to provide a link, so it's not there at the moment. But that's just going to go on here. So we can't use the original screws, they won't be long enough. But we can got some 20mm screws. That will work. So on this part, if you do choose to use it, come on, please focus. You can see there's two like pointy bits on one side, on this side. Those press into the extruder, and it helps position them into the right place. So like that. And then we take our screws and we screw it in as well. That just prevents any sliding left and right, because they're locating directly into the plastic holes. And again, screw it reasonably tightly. You don't want this being loose or wobbly. during the vibration process. That's good. And we can plug it in, I believe. So again, watching your wiring here. So watching this time on here, you want to make sure your VCC is right next to this end. It is labelled on the board, and again, mine is red, so hopefully I can get this right first time. So that's on there. And then the second set I've wired in the same orientation. And I've used a 4-pin because that way there's 2 gaps in the middle, and it's very easy to hopefully get those in the right place and not mess it up. So that wire's just sitting on there. Cool, everything's just super dark, isn't it? Slowly try and get a bit more light. This is a problem with having loads of black parts on the screen. Everything just becomes really dark. Is that a little bit better? Probably not. I did make this. I didn't make it today, obviously, but I have made it. What I might be able to do is, oh no, cancel, share public link, share the latest version. I'm just in Fusion 360 now. Copy. So here's a link. That's the Fusion 360 link, and from there you'll be able to download the STL. I think you can download STL and step file and the original Fusion 360 file all from that link. So that should all just work rather nicely. So next step of the process, close this down. Double check your wiring before powering up the Raspberry Pi to prevent damaging it, or the accelerometer. Hopefully I'm okay. Mounting the accelerometer, we've done that too. So you do want to make sure, as I mentioned earlier, that your directions labelled on your board are matching the principal axes. Well, they don't have to match, they just have to be pointing, like don't set it up diagonally and all kind of squiff and wobbly. Try and get them parallel, collinear with the axis of motion of the printer. The way I've created this board is that X is in the X direction, Y is in Y, and Z is in Z. So you also, not only are they perpendicular to those directions, they're parallel, collinear with those directions, they're also the same letters. So when you get to the graphs, you don't accidentally get confused, which is quite easy to do. So for the software installation, there's a bunch of code to run. Now, I have already done this, as I mentioned, but the way you'll probably want to do it, or the way I've done it, is to use PuTTY, which is an SSH client, I believe is the correct terminology. So you need your IP address of your Raspberry Pi, and then you connect, and then you can send commands. If you've set up Klipper, you've probably already done this. But mine's not turned on, so of course it's not going to connect to anything at the moment. What a fool. Let's close that and try again. Let's make sure this is going to come up first. Oh dear. Pretty sure I turned it on. Oh, I've turned it on, but I forgot to put the power cable in. Turns out that's pretty important. Let's try again. Ooh, the lights have just gone really bright. Huh? What the hell? That was weird. Come on, printer. While that's turning on, we got oh no, we'll leave it a little bit. Up to 64 people. It's pretty good for a weird time of day stream. Don't forget to like the video. Feel free to do a super chat anytime you like. I don't really promote super chats, but if you fancy making a donation thing via super chat, then I would be very welcoming to that. Sure. That's working. Over there. So that's all looking good. So let's try our putty again. So I've saved my configuration here. So to do that, you type in the IP address, type in a name, and then click save, and then it'll save it. So next time you can just double click that, and it'll create your terminal. So logging in, Pi and Raspberry as always. And then you literally just go through these. You can copy the line or the whole thing, and then it does them one at a time. Copy them in there and paste them in here. You'll go through those two first, and that'll take a little while. Oh no, sorry, starting with this one. Do this first, and then do these two. It does take a little while, so that's kind of why I started getting it done off stream, but I ended up doing it all. Don't forget this section here. After you've run these commands, you do need to do this microcontroller document thing here. So this is very similar to how you might have flashed your control board at the beginning. So you go into the this make menu. Oh, let's change directory first. So you'll be using this and setting up Linux process instead, and then you have to flash that. So that's just a slightly different way to how you might have set up your controller board in the beginning. Don't try and do the same way you did before. So this is not flashing the control board, it seems. So don't put it on an SD card and put it in your control board and reboot. That doesn't work. I tried that. Don't do that. Just follow exactly what it says to do here. So change directory, make the menu, stop Klipper, make the flash, start Klipper. I didn't have to do this, but I did it anyway. So you're just giving yourself correct permissions to use the files. After that, I didn't have to do any of this optional additional stuff either. You can also default watch to log in using Pi for the IP address, by the way. Pi@, will log you in as user Pi. So Pi@, oh, okay. That's quite useful. tar. So let's give it a go while we're here. So are you saying in putty, if I do Pi at 192.168.1.123 and I call it okay, well it literally saves me typing 2 characters, I guess. Every little helps. I'm just going to keep the normal one just so it's familiar. But thank you for the tip. So yeah, after you've done that code and run this, you'll obviously have this Linux MCU thing, and then it probably won't connect and it'll go a bit weird. So you have to do the sudo raspberry config, so I'll show you that as well. So you go into this, and then in interface options, you go to SPI, and you want to make sure you select yes here, so that will enable the interface. If it's already enabled, it will stay enabled. After that, you do need to modify your your configuration file, which I'm going to go do now because I removed it. So config, printer, edit. As far as I'm aware, you can put these things anywhere. I keep adding stuff at the bottom. So I've already added in 2 bits of this, so we want to put this in here. And you need to modify these lines here to be in the middle of the printer. So if you're 300 by 300, then you want 150, 150, and then keep that as 20. I bet a rhyming review of Voron on your building experience. The Prussian Mini one was the reason I found this channel. Really? I didn't think that video was particularly popular. But I'm glad that you found it, and thanks for the tip. Tip? Do you call it a tip? Super chat. Is that 10 Australian dollars? Thanks very much. So here we go 150 and 150 plus this bit that's already up here. So I'm pretty sure this is actually overwriting a setting at the beginning. Let's just go have a look. It doesn't overwrite MCU serial. I think it's changing this, is it? Yeah, MCU RPi. No, it is different. $10 for the land of kangaroos. Thanks very much. You know what's funny? People, there was someone in a stream a couple of weeks ago that thought it was from Australia. I thought that was mildly amusing. In Putty you can set a username for that profile. Forgot where, I've not used it in 2 years since I switched to Windows. OpenSSH. Yeah, you're obviously a lot more into the whole coding shenanigans than I am. I just have enough to get by with the stuff I need for 3D printing. So yeah, we've done that. So once you've got your additional config parts that we've just added in down here, this chunk, whoop, sorry, it's not the force move. It's this thing here, and making sure that's right. Then we do the save and restart, which is that button there, I believe. And that, because you've added in that line and modified your Raspberry Pi controller thing, that should then reconnect properly, and there we go, we're in. So the reason I hadn't removed this line, because if I do, it won't be pointing to the right place, and that'll be a bit of a mess. So that's all the kind of the setup, I think. Once you've done all of that, you're ready to start using the accelerometer. So we can test to see if it's going to work by doing this. So accelerometer query, that should give us some informations. So X, Y, Z. I don't know why they seem to be quite high values, even though it's sitting totally still. Reasons, I don't know. And obviously this one here should be basically 9.81 or 9,810-ish, because that's Earth's gravity. If we run the same query again, it'll probably come up with something completely different. Not far off, but X and Y seem to vary quite a lot, even when nothing's really happening. Personally, don't really understand it, don't know really what those values mean. But there you go, that's what it is. If you get values in this range, then I think as far as this process goes, we're close enough. So, if you get an error, then do that. Next, try running measure axis noise. So we're going to place this in here. That's going to measure some noise values. Axis noise for XY axis accelerometer. So 22.46 on X, 21.62 Y, and 56.6 on Z. Should be somewhere in the range of 1 to 100, so that's pretty good. Z's are twice as noisy as XY, but still should be fine. Too high axis noise, like 1,000, is indicating of a problem. So if you have a problem, then you need to fix the problem. It doesn't say how, it doesn't say why, but you have a problem. I would guess it's probably wiring related or a PCB issue or maybe something like that. I would personally maybe remake your wiring or re-terminate the ends. As a first port of call, that's probably the easiest thing to do. If that fails, maybe you have to get a new sensor. hopefully one of those things fixes it for you. Now you can run some real life tests. Run the following command. So there's two ways to do this. There's an automatic way. Do you want to look at me for a second while I explain? So there's two ways to do this. There's an automatic way and there's like a manual way. They're basically the same. But obviously the automatic way it does all the same things. It just requires one command instead of like 5. So it doesn't really matter what you do. There is a bit of manual in it anyway because you have to add some stuff to the printer config because one of the values won't add even if you do it via the automatic method. So it's only semi-automatic at best, but it's still very automatic. So do you want to, shall I just do the full manual method? It's not very manual anyway, it's pretty easy. So test resonances axis equals X. So this will obviously test the X axis. So let's do that first. Note that it will create vibrations. Or like, I mean, it's a lot of vibration. You need to just be careful. Like, if you have a slightly wobbly table, put your printer on the floor. It's like, really, it's a lot of vibration. And it's quite a big frequency range, so other things around will start to vibrate as well. So do be a little bit careful. As it says here, be sure to observe the printer, keep a 112 command close by. So to run it, we can stick that in there and we click send. So while there's not much to look at, you'll see the printer head vibrate for the first few because the frequency is very low. As it increases, it will basically look like it's not moving, but it'll be vibrating very, very quickly. So let's run that. You'll also see here, oh, bloody thing first. I don't think that is the point to put it in the place where you're going to use it, because the frame should be sufficiently rigid so as not to be impacted by anything else around it. Obviously the accelerometer will be, but a wobbly table shouldn't impact your print quality, because as long as the head stays in the same position relative to the bed, that's what's going to be determining your print quality. It's interesting that maybe you've obviously had recommendations to the opposite, but so it will change your values obviously because the accelerometer is relative to like the earth rather than just the printer, but the printer shouldn't need different values based on its location. In my mind, that seems odd that it would. So we'll move this over to the middle. And move this also to the middle, and we'll move this up a smidgen. Nope, didn't want to. Doesn't seem to be in this documentation, might be in some different one. It might be in this Voron design documents, because for some reason they've got loads of documents and loads of places. I suppose this is Klipper, whereas that's Voron. So, let's try again. Test resonances axis equals X. Oh, it has a specific height. So there you can see it moving to begin with, but very quickly it's going to go past a range that you can't really see. And you see the frequency that it's currently testing in here. So it goes up to, I think, 133 Hertz, so that will give you an idea of how long it's taking. Well, it's basically 1 second for each test. I don't know how this is going to affect the microphone. Hopefully there won't be any weirdness going on, but I apologise in advance if something does happen. I can hear a loose screw, don't know where it is. There is a warning not to do this on a regular basis. The printer's obviously not designed to withstand this kind of level of vibration regularly. So don't do it before every print or anything like that. But do it when you need to. This is now shaking the entire house at 80 Hertz, and we're through that range. It is weird because like everything in the room will like vibrate with this at some point. Well, that's a bit of an exaggeration, not everything, but you do find they're like, oh, then this, and then that, and then this, and then that, as you go through the range. Up to 100 Hertz, 105, 106, 107, 108. Not too loud, which is good. Not too much weirdness going on in anything else breaking. No screws falling out. So there's not much to look at when doing this. Once we've run it for X, we literally just take pretty much the same command and run it for Y. And that should be it, 133 Hertz, all done. So I think it does a little bit of processing first, and then it'll be ready to do the next one. Resonance data written to file. So that tells me that that's done, and it's made the CSV, which is kind of like Excel, like comma separated values, that stands for. So I'm just going to scroll back up here, take this, and switch X for Y. Let's use a capital just in case it matters. I'm not sure it does. And this will do the exact same thing, but vibrate the Y-axis rather than X. And it's going to start at 9 Hertz for some weird reason. The whole desk is wobbling. And then the monitors go, and then the arm goes. Because this axis has way more mass. It has a much bigger effect on everything else around it. You can tell the printer, there's a lot of the printer reacting in the frequency range of 40-ish, because around there, everything on the printer is just like... Now, it's a bit more audible, but there seems to be less to do. Oh yeah, I've been using up-down arrows most of the time, to be honest. The reason I've stopped using it as much is because it's laggy as hell. And sometimes if you try and press it twice, it just only comes once, and it's just annoying. So that's why I generally have stopped using the up-down arrow thing for previous commands. Much better in like putty, because it actually responds when you press it. No, this is very quiet now. Doesn't seem to be much going on. So some people are saying you have to rerun the input shaper every time you move your printer. I can't see a reason why you would. You would get a different result, I would agree with that, because it will depend on the surface that you put it on. My point is that you should do it on the most rigid surface you have to try and measure the printer resonances, because that's the stuff that's going to affect the print. Hopefully that makes sense. That would be my recommendation, although I haven't tested it, but the principles of how it's working tell me that that should be a good way. Plus, if you're moving your printer regularly and you keep running this enormous vibration frequency stuff through it, it's going to not really like you very much. Okay, so that's finished doing that now. So we've gone 5 or 10 to 133 Hertz on the X and Y axes. Both processes are complete. So we come over back to here. And this is what you modify if you're having problems, then do this, and then you have these two scripts to do some other stuff. So this is going to take the, it's going to run a Python script, reading the CSV values and output an image. Yeah, it's really not portable, is it? Especially once you've got the panels on, there's no way to lift it. So take it outside and stick it on the tarmac. So back to putty. So this is using, oh, that's just gone straight in. So that's one command and it's running it straight away. You don't need to worry too much about the text that it outputs here. You could read through it and it does give you the answers that you need if you wanted to do it that way, but it's much nicer to look at a pretty image. And the image is also a little bit easier to read, especially if you end up in this scenario where your window is too narrow and it puts it all like partly on new lines. So that's those two commands. We should now have those two images ready to look at. What was the command? Control D. Nice. So the best one to for this is WinSCP. If you want to know a little bit more about how to use it, I showed that on my previous stream. So temp won't normally be where you start. This will be the normal home directory, so home pi. But you're looking for temp, the temp directory, basically tmp shapecalibrate.png. So to do that, you can go right back to home. So you want to go up. How did I do it before? Root, and then go tmp, and your PNG should be in here. So hopefully these are today's date with recent time. Yes. So we can open these one at a time. Oh, not like that. Let's move them over here fast. You can see the ones that I did before. Append. Append. Oh, that's overwritten them anyway. Okay, sure. Oh, why does it keep using that? Okay, we'll just close that. We've copied them to desktop now. No, desktop, 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 desktop. There we go. Okay. So, shape calibrate Y and shape calibrate X. So these are our two graphs. There'll be some summary information in the top right corner here about each of the different models. So these are 5 different methods for doing input shaping. So they presumably function using slightly different equations for compensation. So good for different scenarios. And then there's a recommendation right at the bottom here. Recommended shaper here is MZV, and recommended shaper here is also MZV. Now, the recommendation is not necessarily the best, but it is recommended. So it's, if you have no other way to make any other decision, then it's best to just go with the recommended. If you want to try the others, you probably could. It shouldn't damage anything, but you would expect the best results from the recommended shaper. You can see there's very much a 2-peak scenario going on here, but it still does recommend MZV. So we're going to go with MZV. You also want to look for MZV up here, and this will give you a recommended acceleration peak value. So MZV 39 Hz, vibration 1.5%, acceleration less than or equal to 4,500. This one says acceleration less than or equal to 7,600. Because on Klipper it uses the same acceleration value for X and Y, you need to pick the smaller of these two values to be your maximum acceleration. So for us, it's going to be, well, we could go less than 4,500. We could do maybe 4,000 or something, but I'm probably just going to stick to 4,500. Very nice. So once we've done that, we can add a bunch of stuff to our config file. So I'm going to copy this whole segment here. We need to go to Klipper configuration file, edit it. I'm going to go down to the bottom again, just because that's where I'm adding new things. And we'll stick it below here. This line confuses the hell out of me. I'm pretty sure that works just as well. So I'm going to put that back up there because then it's a bit easier to read. I think so anyway. You can resize the putty window or even set it to the config to be larger by default. Yeah, I mean, you could make the putty window a little bigger if you wanted to just read out the values, but it's nice just to have a pretty picture in it, especially since you're there anyway. So, shape of frequency. So this is where we need our graphs to be able to read off the values that we generated. So we're going to be basically transposing this information into here. So shape of frequency X, so we need the frequency from the model that we're using. So MZV is 50.8. And then the type for X is going to be MZV. We need to get rid of this. This is the default values. We're using MZV for Y, so we can keep that there. And for this is 39.0. And again, model is MZV. So that's the input shape of parameters. And our max acceleration, as I said, it even suggests here, should not exceed estimated max for X and Y. So the minimum of both was 4,500. I think that's all we need for now, so we can save and restart. As it says here, you can choose different calibration if you want. Alternatively, you can run input shape auto calibration directly, which can be convenient. So if you run the command shaper calibrate, you can basically do all of the stuff that I just did in one command. So that'll run for X, it'll run for Y, it'll create your graphs, and I think it does, yeah, you can do save config at the end to save the parameters. However, you do have to do the max acceleration value yourself. So it saves you a bit, and if you're going to be doing it repeatedly, if you are doing it each time you move your printer and you move a little while, then you may want to do something different. But hopefully that helps. If you do have a bed slinger, then you need either two sensors if you want to run them at the same time, or you have to do one and then the other. Keep in mind that input shaper can create some smoothing in parts, automatic tuning of the input shaper, So this is not actually, I don't think we're going to worry about this for now. Input shaper auto calibrate, offline processing. Okay, cool. We could do pressure advance as well. I think that involves some printing, doesn't it? Yeah, so we're not going to do that. We should run a second advert. This live stream would not have been possible without our sponsors, Filafarm and Big Tree Tech. Filafarm are a 3D printing bed specialist based in Germany. Filaprint is their high-performance, durable print surface designed to grip parts tightly when hot, but release them when cold. Their switch system utilises a strong magnetic sticker and 0.6mm spring steel to allow for easy swapping of bed surfaces. The bed plates offered are made from cast aluminium plate and are extremely flat, helping you get the best adhesion across the whole first layer. All of this can be made to standard sizes or customised upon request. Keep on watching to find out more, or follow the links in the video description. The Big Tree Tech Octopus is a 32-bit control board with loads of connectivity options for performance 3D printers like the Voron 2.4 and RapRig VCore 3. It can connect up to 8 stepper drivers, 8 fans, 6 end stops, 5 thermistors, 4 heaters plus BL Touch, RGB LEDs, a TFT screen, USB-C and more. Pairing the Octopus with TMC 2209 stepper motor drivers allows for quiet operation using Stealth Chop, performance using Spread Cycle and Stoolguard for sensorless homing. Big Tree Tech also offer a mini 12864 display, which is ideal for the Voron 2.4 design. Check the links in the description to find out more. Everything is looking pretty good now, isn't it? We've got a lot of setup done. We're almost ready to print. Before we're doing any printing, we are going to put the whole enclosure on. We could maybe even do that. Start that now. Do need to do bed surface. That could be a good job to get done. Maybe we'll do that. Got to have a bed surface at some point. Do need to remove the sensor though. Let's remove the sensor because we definitely can't continue with that sitting on there. I'm going to turn this all off just in case I accidentally jab a screwdriver into something that I don't want to. So now that we've tuned everything, we don't need this accelerometer. Could be worth trying out some other things, but for now, oh, screwdriver, I'm just going to take it off. We've got our input shaper configured and it should be close enough. I would expect a Bowden tube to have a significant impact on the frequency, so you may want to make sure that that's installed if you have one, or retune it after you've fitted it as well. Back to the shorter screws. It's a bit of a shame these screws are silvery zinc plated instead of black, but you can't have it all, can you? Very easy, and let's unplug. People have created mods I've seen that allow you to add connectors like into these hexagons, so you don't have to plug stuff in right underneath like this because it's a bit of a pain. But that's that out of the way. Don't need a cable. Right. Righty-hoo. So we've got our PIDs, we've got our input shaping, pressure advance we're not going to do until after we've done printing. Yep, surface it is. Extruder steps are done as well. Oh, by the way, don't forget to leave a like. I'm going to keep saying that because I can. That can stay attached there for now. Good. I'm going to move the printer out of the way, I think, so we can fit this print surface without any stuff in the way. That should be flat enough. It's pretty heavy now. So I've got two of these plates, so we've got one on the printer, but I'm going to be doing this one first. And it's very important that these surfaces from filler foam, you don't touch the surface of, because you can't clean them with, what is this camera angle? You can't clean them with IPA or acetone as it damages the surface. So yes, don't do that. What you can do though, is clean the steel that you're going to stick them to. So some of that, some of this, some gloves. I kind of don't want to damage the desk. Stick that panel underneath. What else do I need? What else do I need? Sticky down, then this, then that. Cool. So, let's get some gloves out. First step is going to be to clean this sheet so it's clean, obviously. If you've got any residue on here, it will impact the stickiness. Starting to get very low on IPA. Don't know if I have more actually. So you can see how much dirt does come off. Definitely worth a clean. And I would also be very wary of any particles. You don't want little things getting stuck between these two surfaces either. So make sure everything's out the way. Hopefully I don't make a mess of this like I did with the heater. So there's no excess on here in terms of corners, so we've got to line it up nicely and not mess it up. Although maybe it is about 1 millimeter larger, so. I'm going to go for the full edge method. It is quite stiff, this surface as well, so that makes it a bit more difficult. Be very careful not to let it stick to anything like your gloves. It is a one-time deal, so be careful. Let's try and get this. Maybe I'm being overly cautious, I just don't want to mess it up. That looks good. Let's clear. Not sure that's going to work very well. There is some recommended tips, I think. Probably should have read this before I started sticking it on. Clean your printer bed. A clean and greaseless surface is a perfect base. Remove the protective sheet. Place it flush on one side. Stick the print surface. If you haven't ordered a print surface, use this. Place the switch plate on your print surface. Okay, I'm doing it right. It's just, this is not the, I don't really want to use that. This is difficult. This is why these rigid surfaces are always a bit more of a challenge. There comes a point where you just have to go for it. Looks like I've got a little something in there, but other than that, it's looking pretty good. Very slight overhang on one edge. It's one of my best installs yet. All the others are absolutely perfect. Nailed it. Absolutely nailed it. So, what I think would be really useful with these surfaces is a cover. Like, because unless you're printing constantly every day, you really don't want to be getting dust and stuff on it, which is why it's nice that it's going to be in the Voron enclosure. Otherwise it'd be nice to have like a thing to put over it when you're not printing, so it doesn't just gather all that kind of weird dust. So should we put the print surface on, or should we leave it tucked away for now? I think we might leave it tucked away for now. Keep it clean. We'll probably do the other one at some point, but just need the one for now. I suppose we could start on the printed panels as well. Enclosure panels, not printed panels. Right. Who wants me to do the printed, why do I keep calling it printed panels? Enclosure panels. Should I do the enclosure panels? This is the question. I think they're going to take a little while to do. A lot of it may not be very interesting, so I think it's good to get it started and get it done. And then maybe tonight, GMT, we can do the first print. That would be cool. A washcloth doesn't sound like an ideal thing, but I was thinking like a silicone mat or something. That would be just a really thin piece of silicone. Yeah, that's a good point. You can zip tie that there. That is a lovely idea. Thank you for mentioning that. That's very much appreciated. I was wondering what I was going to do with the belts when we got to the enclosure. So, oh, that's that camera that's a bit wonky. Anyway, so I guess if we find the manual, we should probably do a quick check on that. So this is all skirts. I don't think enclosures before that, is it? No. Panels. This stuff. Use VHB tape to attach latches. You should have VHB tape as part of your bill of materials. Use it to secure the panel latches to the polycard panels. I think it's time, ladies and gentlemen. It is time. Ooh, LEDs. LEDs. We're going to do LEDs. we were going to do enclosure panels, but we're doing LEDs. Almost forgot about lighting, the most important part. No, not really, but it's good to get some lights. Dark printers is not great. I think an LDO kit of the 0.1 is probably a really good Voron place to start, because by all accounts everything is really well included. Really well included, that seems like an odd statement, but like everything's included, so there's not sourcing to do. There shouldn't be much like weird configuration and stuff. I think that would be a good place to start. So LEDs wise, I've got some 12 volt, 24 volt LED strip, and these which are a Voron mod. My concern at the moment is where the hell the wire is going to go from top to bottom. So let's bring this back and have a look. So I was thinking the wire would go near the back somewhere, but there's nothing else wired up the top, so how the hell do we get lights up there? I suppose we could do the lighting near the bottom, but that would be weird. That would be cool, actually. That would be really rather cool. So, let's get the right camera angle view, eh? So, the parts I have, like lots of them, and they look like this. So, they look like that. Oh, come on. I've hollowed them out so they take very little plastic, and they should just kind of press into the extrusion with this side, and then with this slot you can put the LED strip in it like this, and everything holds in place nicely. And you're not too reliant on the adhesive because it should hold in without it. And then you just put a whole bunch of those and you get this nice baffle so nothing blinds you when you look at your own printer. So that's what I want to install. And I think the place to do that is up here. So on these rails, so they're up here and pointing downwards. They fit there nicely. They would be pointing nicely down onto the printer. Although it would be a bit dark under the nozzle, I still think that's a reasonably good place. But getting wires up to the top might not be the easiest thing, because this occupies like this whole channel all the way up. how are we going to put these in? Tres difficile. Need some wiring. I've used all the wiring that came with it. It came with that kit for other stuff. Do have some more wires. I could use silicon wiring. Lots of random wires. So we've got whole spools of like silicon wire we could use. This stuff on here tends to be a bit too high gauge for the XH connectors. This could be maybe a bit thin, I'm not sure. This is basically like Ethernet cable twisted pairs. Or we've got the hell of the PTFE wires. Trouble is, I don't think it's going to go anywhere near this gantry. I don't know how we're going to keep the wires in the channel to get all the way up to the top. That's really what we want, I think. So, let's have a try. I'm not sure I want to use this expensive wire just for some LEDs. I think this silicone wire is probably going to be okay. Let's use that. It doesn't terminate quite as well, but okay. Sorry. It's weird streaming times to get things completed. I need a quick break, so we'll be back in like 2 minutes. It's just going to be a quick ad spot. See you in about 2-3 minutes-ish. This live stream would not have been possible without our sponsors, Filafarm and Big Tree Tech. Filafarm are a 3D printing bed specialist based in Germany. Filaprint is their high-performance, durable print surface designed to grip parts tightly when hot, but release them when cold. Their switch system utilises a strong magnetic sticker and 0.6mm spring steel to allow for easy swapping of bed surfaces. The bed plates offered are made from cast aluminium plate and are extremely flat, helping you get the best adhesion across the whole first layer. All of this can be made to standard sizes or customised upon request. Keep on watching to find out more, or follow the links in the video description. The Big Tree Tech Octopus is a 32-bit control board with loads of connectivity options for performance 3D printers like the Voron 2.4 and Raprig VCore 3. It can connect up to 8 stepper drivers, 8 fans, 6 end stops, 5 thermistors, 4 heaters plus BL Touch, RGB LEDs, a TFT screen, USB-C and more. Pairing the Octopus with TMC 2209 stepper motor drivers allows for quiet operation using Stealth Chop, performance using Spread Cycle and Stool Guard for sensorless homing. Big Tree Tech also offer a mini 12864 display, which is ideal for the Voron 2.4 design. Check the links in the description to find out more. Okie dokie, let's carry on. So my idea is, if I can have some tension in the cable between the top and the bottom and use a clip to force it into the extrusion, then we should be able to set it in there. It won't come out. That seems reasonably safe. As long as we keep a bit of attention on it, because if it goes slack, it pops out like this. Can you sort of see that? Could make some very thin covers that we can push onto here. I know what I've got. It's totally the wrong colour, but it might be. This stuff. So this is designed to push into the extrusions like so. Unfortunately, it doesn't really provide any space on the inside for a cable. I'm not sure how much that's going to help. Oh no, that could be good. Okay. Unfortunately, it's bright yellow, which is like really not what I want, but sometimes you just got to go with what you've got, right? So I think we can cut a few lengths of this. I could just push it all the way in bottom to top, I suppose. Oh, I hate that it's yellow. I want something that's black. Or blue, or ABS. Just blue ABS coloured. Oh, I haven't got anything better at the moment. Some really, literally the same printed parts, just thin would be okay. Let's see what we've got. So, what I've done, so this clip, so this is the clip that I've modified to make this design. So it's just kind of hollow, but I just want that face. I can basically save a copy of this. Rename. And then I'm just going to be really lazy. We could like properly modify, but I'm just going to be super lazy. And split body using this face. It's just going to expand out. And then we can just remove that body. Ta-da! This is not going to print quite as well, is it? I suppose we don't need it that tall. Let's do some more lazy editing. Should we just do that? Print it on its side. 0.9mm, it's really thin. We needn't have these come out quite so far. That could be pretty good, I reckon. I don't think we're going to gain anything by having much different. Might make this a smidge thicker. See how much room we've got. This is difficult to measure. The calipers are not going to work for that. Yeah, not much at all. I'll fix this. 1.5 millimeters. That should be okay. That's the thickness of this. That's 1 millimeter. So a bit thicker than that. Gantry should never twist too much, so that should be reasonable. What do we reckon? I think that's pretty cool. Kind of want a chamfer or whatnot, but I don't think it's going to really make a difference because it's so small. So I think if I just print one of these for now, oh, okay, it's saved as the same thing. Teeny tiny. I might make those clips a little bit thicker. I think that's going to be okay in this scenario because it's very, very short. Have I edited the wrong one? I have edited the wrong one. What an idiot. Oh, you fool. Doesn't matter. Unfortunately, reload from STL doesn't really work when doing this because it makes a new file name each time. Detect thin walls. Yeah, I reckon that's going to be a little bit better maybe. I wish I hadn't bothered with that fillet, but it's okay. That's going to stiffen up this joint as well actually. Well, we'll print one, it only takes 3 minutes. Infill's irrelevant, there is no infill, it's all just perimeters. Those skirts and brims are excessive, aren't they? Why is there 3? Okay, whatever, that's fine. Where's my SD card reader? Send that straight to there. Eject. Let's print it out. And then while that's printing, we can have a go with the LEDs, get them set up with some wires and whatnot. Right. So, LED strips first. I kind of want them as much of this width as I can. That's going to be right on the limit there. Yep, I reckon that's good. So we should be able to cut that there. And that wires that side. And then we do the same up the other side. That gives us 2 strips. Now, how are we going to show me doing the... So these just push into the top here like that. I don't know if I want to wire these up before putting them all in, or this should be flexible enough. I think this is going to work okay, that we just can take them in and out if we need to. I mean, this whole lot should just pop off, so probably easier to wire them first, but difficult to get the wire length right until we've got them all in. So I know, let's just put 2 or 3 in. That will give us an approximate position. So that in there. So let's tip that forwards. Is that going to be okay? Doesn't? Oh, it does. It puts all the weight on the display. Don't want to do that. About that way. Where's the LED? So LED's up there, it's coming all the way down, and we're going into something on here. These, isn't it? So 2 of these are going to be now for LEDs. We could chuck them both in the same one probably, but chat's gone quiet. Everyone okay? How long a cable wire do we need? Oh, this is really long. So we've got a convenient gap in the chassis here. hole in the floor plate. And it's going to find a way over here. And then up the top to here. Over, this is way too long. So that's going to back behind there, up to there, bit of extra length. Okay, so that's going over there, round there. All the way down there. Around there, down, in through there, along and down here. So if we make it extra long and cut it down, that'll be okay. Probably shouldn't use scissors, but it's only a little cable, so it'll be alright. Then we'll make another one the same for... Oh no, we don't want another one the same for the other side, do we? Second one's going to have to be longer. Our little clip is done. It's tiny. It's absolutely tiny. Shouldn't be a surprise, but for some reason it is. This is how teeny tiny it is. Oh yes, the Australians have gone to bed. So the question is, does this fit nicely in here? Yes, that works absolutely perfectly. Not too rigid, not too soft. Could be longer, because at the moment it can kind of twist. Oh, it doesn't really. These are pretty good. Let's make some more. My printer is really dying in that heat in there. Does not like being fully enclosed. So I'm going to set up a bed of 6, or maybe we should do a couple more than that. 8. It's a Prusa, and for some reason it's just had a bed preheat error. It's a Prusa Mark 3S, well, modified to Mark 3S. Now, there's a Sidewinder X2 under there as well, but I've not used it. Okay, so that's all off going. Let's get back to this. So, wiring up, we'll just do one for now, I think. Let's pull that out of there. I've just put that I've just wired this for the wrong side. This is coming down the front. I want it down the back. Oh, you fool. This wire is going to be way too short, so let's start again. Oops, daisy. Oh. That to there, that to there, that all the way down there, that across to there, that down through there. Maybe a bit for that, and then kind of across here and down here. So that length instead, with some extra. That's okay, and the same in black. Let's get the soldering iron headed up. Probably want a bit of sleeve, do we? Heat shrink sleeve would be a little bit more professional, but I'm not sure I have any of the right size. Here's a random bundle of heat shrink sleeving. Is that going to fit over there? No, so that's not going to be wide enough. Is that going to fit over there? This should fit. Let's try a bit of that. Oh, I forgot to plug my soldering iron in, so that's not going to work very well, is it? This is a Voron. Voron 2.4, 300mm to be precise. It is quite an expensive machine though. Oh, come on, there we go. That should be a reasonable tip. Yep. So hopefully not going to damage the table doing this that we have. So I can put it on here, but then that's going to sink away all the heat, which we really don't want. A small piece of wood would be ideal, but this is what we got. So where's my solder? So solder onto the pad first. Then I'm going to tin the wires. Now we're going to add the wire onto the pad. It's not really shrunk properly, but the trouble with having something really wide and narrow on the same piece of shrink is it needs to shrink more to get the cables, but it's okay. So I kind of want to test this as well before we go too far. So let's take this and this off the ends. My nose is running again. Excuse me a minute. Okay, so we should be able to wire this up into here. I'm currently planning on getting the full rat rig VCore 3 with lid, stand and panels. Just wondering which hot end extruder comma to go with. Obviously I've only tested one, but I would go for something high flow rather than the V6, and I would probably recommend the Klipper version rather than the Duet version. So this is not powered on, so that's good. Need to undo these terminals. This is a bit difficult. Can't see anything. Oh, lost my negative cable. How much would it cost to get a similar rat rig to what we see on screen? Well, this is not a rat rig. So hopefully we can turn this on. Oh, similar rig to what we see on screen. There's a link in the video description to a Google Sheet which has everything on there. All the prices, well, values, where they came from, etc. And there's a total at the bottom if I remember correctly. So, obviously we don't see any LEDs turning on at the moment. Something smells funky, but I think it's just the printer. Display. Ah. We can set the knob on this display. To a darker colour, because the LED, oh, it doesn't matter. Display, display, 4 pins, LED control, case light. HE1 is what I'm in. Pin PA3 presumably, shutdown value. Brilliant. Something really does smell a bit funky. Oh, it might be this. It's probably this. Let's turn that off. Oh, printer.cfg gets it every time. What I will probably do at some point is take out all the extra comments that I don't need. It'll make it a bit easier. So that's just shouldn't be on a separate line like that. Oh, was that just a comment? Does that not need to be? I think this doesn't need a thing, is it? This is not a thing. Oh, blimey, Charlie. It's bright as the sun. I'm blind. Oh, okay. Output pins. Pins configured here will set up as output pins, and one may modify the runtime. Set pin equals my pin value equals 1. Okay. Pin static value. Pin is assigned to this value at startup, and the pin cannot be changed. So what I've done before is have it so when you press a button, it cycles between like 20%, 80%, and nothing. So that would be ideal, but at the moment, I think we're just going to keep it simple and just have it on, but not too bright. There we go. That's on. It makes light, but it's not blinding. It's quite blinding for the camera, but it's not blinding. It's getting rather warm. Well, it was at 100% PWM, so I guess it doesn't surprise me. It has removed every single message you've ever sent. Yep. Soz. So my clips are done. It's going to get you again because you've done printer.cfg. See ya. It's alright, I can still see your message, so I saw it. I did see your message, but it does get removed. Nobody else can see it, I don't think, just me. But I have seen it. Unfortunately, I can't undelete them. Right. So this is good. Das ist gut, ja. And then this is going to come, so we don't need this in here. Let's see if we can fit. Printer underscore CFG? There is no printer underscore CFG. What on earth do you mean? How could I possibly understand? Can't really see this, can you? Oops, that's the mains cable I've just dragged across the table. So here, I'm just getting these clips, add it in, squidge the cable down a bit. Add the next one. Squidge the cable down a bit. Be easier just to add a few, wouldn't it? Don't know how these are going to stay in after the fact, after everything's powered up and hot and everything. I mean, they're printed out of ABS, so it should be okay, but wear them down a bit. Need some tweezers. Where's my tweezers? Need one more, I think. By jamming this heat shrink tube in the end, it's going to set a position for the wall as well. Unfortunately, I didn't get all my baffles quite positioned correctly, so that was silly me, because the lights are positioned 60 per meter, which means you have 16.67 millimeters, I think, isn't it? Is it 60 a meter? Something like that. So it's important, or relatively important, or just helps the overall outcome if you have the baffles all at the right distance, so they stay in the middle of the lights the whole time. So I'm going to take a couple off, move everything down. Should be able to just so you just want one baffle per LED. So mine's got lots of little gaps, but the file I've modified doesn't. It has them all positioned nicely. I'd quite like another one in the end. Because otherwise the end LED is still going to blind me. Right, now we can use these little clips, hopefully, to route this cable back to the start. Oops, amazing. Where are we going? Back over here. Tiny little clips. Used more clips than I wanted to. Can we reduce the clip usage? Make a series like you made Steve and make your own design of Core XY printer. Steve was my own design of Core XY printer, so I've already done that. Would the WS2813 work in this sort of setup with an octopus? The LED stuff kind of confuses me. I don't know what a WS2813 is. Addressable RGB. I'm not sure. I don't know. I think different LEDs, different RGB LEDs use different protocols for their digital signal thing, so I think it depends. But I'm not 100%. So I want to get this through here, really. Because no, that's not worth it. Yeah, I do want to come through this panel. Annoyingly, there's not really space. I have to try and cut a piece out of it while it's already installed. It's not going to be ideal. Can't just... Could kind of just squeeze it through, but it's going to damage the cables, I reckon. I suppose I should probably do it right in here. It's kind of messy, but gives me a little hole to poke the cables through. A little advantage to this cheap plastic material is it's very easy to just cut and hack when you feel like it. Just thought you probably can't see a thing of what I'm doing, can you? Suffice to say, I think that's absolutely nailed it. I'll try and... So... Oh, that's quite a good angle, actually, isn't it? Can we see from there? Let's bring those down a bit. So you can see up there, that's where the LED strips are, and you can see the way, because it's baffled, when you're at an acute angle, like down here, you can't see the LED, so you'll see the effect, but you won't get that blinding effect of it shining right in your eyes. And then it comes all the way along here, round the back, through this little gap and onto this clip here, which then runs all the way down the side. It looks like it sticks out a bit, but it should be fine. Hopefully, mostly, because of these clips. A few more clips would probably be good. They are a little bit loosey-goosey, which is not maybe ideal. I think it's just as they've cooled a bit there, they've shrunk a tiny amount. Over time, I expect these are going to vibrate and all fall down, which is really not what we want at all. So some modifications of those may be required. So that lot comes all the way down there, around this little extra clip at the bottom, which is, oh, see, that one just fell down regardless. Not even done anything yet, and it's starting to fall down. Just going to bend it out a little bit. Stresses the plastic a bit, but that should hold a little better. And that lot just goes then, oh, what's happened? There we go. So yeah, that lot comes down there through a little clip and then into the basement. Should we call it let's call it a basement, through a little hole. I made this dodgy hole as well, so that looks a horrible mess. I want more of these clips. These clips are pretty good, aren't they? They are a little bit loose. I think what we can do, let's go back here. See, because I've modified it from this original STL, it's not the same, it's not, I don't have the sketch I can just modify. So best way to do it, I think, is going to be to move faces. We'll take this face, this face, this face, and this face, and this face, and move it this way, 0.05. And then we'll do the same command on this face, this face, this face, this face, and this face. And that'll be 0.05. So that's 0.1 total. Hopefully that's enough. Did we thicken those? We have. Thicken them a bit more. A little bit less space for cables, but this is going to be 0.4 radius anyway. That's okay, isn't it? What I might also do is bring this down 0.5. And then I'm also going to make it maybe, we cut it down from the other size, didn't we? Where did we do that? Here. Maybe make it 2 mil longer, taller. Good little chunky clip. See, the problem really, I think, is, well, by the time you've put a point fill rad on that, that's what it actually comes out like, because it can't draw a point, can it? Do we want to do it anymore? We'll give that a go. Trouble is, the less it bends, the less durable it is for putting in and out. Save as mesh. It's been a long stream today, 3.5 hours, and we're not done. Don't forget to leave a like, just in case you've forgotten. And a subscribe for reasons. So let's just compare. Yeah, so like 30% taller, a bit more chunky, clips a little bit wider. Get rid of those. Oh. Export it straight to the SD card. Doesn't work very well, that. Okie dokie. So what were we doing? LED strips. So do I have enough of these to do the LED strip on the other side? Because I've used quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I think I paid 40, so I should do. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. Got enough for the strip on the other side. Oh, there's another one over there, 21. Cool. Plenty. So, that cable's just going to go under there until we sort that. So I guess first step is to get the cable length, so we're going to spin her around. Stick this clip up here so we don't lose track of what side we're putting this in. No, not that. Oh, we could do that. Are they supposed to go there? Rather than right on the top. I suppose they could be either, couldn't they? Could do them there. Would that be nicer? It's a bit late now. I'm on the top. Yeah, it's alright. This looks pretty good. Okay, so that's there. Now we're going to have to tilt the whole printer. Lovely jubbly. So where are we going? This is going to come down through here. And there to, where's the other LED? Oh, this is coming right in the mains area. It's not ideal, is it? We're going to go all the way across. We could go across the top and match this one. Use the same down channel. That might be wise. We could wire them both together, that could be possible as well. You know what, I think I'm going to go across the top. It's a longer trip by a significant margin. But it saves me wiring low voltage all the way through there. So let's do that. Through here, over here, down there, across down here, join these clips along here, go down here through that hole there, do this across here, with extra length here. Oh my god, why are you stream so? Because I've got lots to do and I want to get it done. So I'm doing like a marathon stream, it looks like. I'll stop for lunch and then I might even start again after lunch. I kind of want to do the final print or first print this evening, that's my goal. Okie dokie. Oh, I forgot to put this on. It is a different time, and I understand that that might be frustrating for some people. At the end of the day, all the live streams are available for everyone. So you can watch them at the normal time, you just get less of the live interaction. Second LED strip. I can start wiring it up, clipping it up, I suppose is the correct term. Clipper it up. So, same sort of dealio. Apart from it's all back to front, isn't it? So, let's get this in here. Can I thread these on? Is that going to be easier? Maybe for the first few, but probably not after that. So let's get them aligned to the LEDs. I've done this a weird way, haven't I? It'll work, I think. We'll be good. Oops, it is. I'm hearing my parts come off as they're printing. I think we're going to end up with a big mess instead of some nice clips. No, seems to be okay. Heard some worrying noises, but oh, I had it again. Yeah, one of them's okay. We'll hope for the best. Hopefully the rest of them will sort of survive. In the meantime, we'll just wing it. I don't think you've really missed much in this stream. We've done like PIDs and things. Oh, no. I think it's going to be difficult when it gets to the end. It might not work very well. I suppose we can put a few on, clip them all up together. So 1, 2, 3. Oh, missed. 3, 4. Maybe enough. That there, there, there. Two more. This is where the exclude print area would be helpful. Yeah. I'm sitting here just feeling anxious now because of the prints. I think it's only damaged 2 of them, so I think we might be okay. Let's probably stand it back up. That's going to go over there, down this here. Oh no, we're not. We're not going back there, are we? We're going over to the other side. Following that back down. We might need to make an adjustment here. Oh, there should be plenty of space. Why aren't you going through? No, it just doesn't want to. This was what? How did I push it up before? Did I do it? Did I just? Must have done. It's quite heavy. I wouldn't say it's like the heaviest printer I've ever had. I mean, compared to like an Ender 3, yes, it's heavy, but as big printers go, it's not that bad. A little bit messy. Get that lot in there and they'll be good as gold. It's just got massive droop at the moment. Substitute these while we're now back onto the side. Because we're going to... Oh, that's come through in a weird place. How on earth has that happened? I'm missing a black cable here. Cool. Didn't leave myself much room. Enough though. So I guess we could. What's going to be the best way to terminate these? Trouble is these. I know that will be okay. I think those connectors will be okay. We'll use some of those. Where's my side cutter? It's gone. Put them away. Don't actually know which pairs for which wires for which LEDs now, but never mind. It is nearing completion. Yeah, the sort of plan is to have everything ready for final print this evening. So that's those. Now we need some terminals. Bootlace ferrules is what we're going to be using with an appropriate tool. Hopefully an appropriate this. What wire gauge are these? So I think it 24, 22, 22, 18, oh, it only goes to 22. Hopefully these will be alright. Have we got 16? That doesn't look right. 20, 22. This doesn't look right at all, but I'm not sure the outside matches up to what's on the inside. Because these are small, but this says 5AWG. Oh, blue, green, yellow, red, white, black is 20. Blue, green, yellow, red, white, black, that's that lot. So we use orange and we use yellow. No, I've had these wire strippers for years. Oh man. It's like a bomb's gone off in here. How many good ones did we get? 1, 2, 3, 4. The others are rubbish. No, maybe that's okay. 5. Can we salvage this? I think we can. Got lots of extra rubbish all over it, but right, and then that's rubbish. That's okay though. Right, we've got those clips. Do want some more, but I might just start it straight away while the chamber's warm, and that should stop it coming off. Need a better way. Who can make a suggestion? Like a quick, easy, open-y, closey for this. Right. So probably need to first check how deep this is. Should be okay. And then how much we've stripped. We need to strip more. Okie dokie. So red is going to be orange. That's good. Excellent. The reason IDEX is good is on a farm, the biggest impact you can have on increasing production is your density of extruders / hot ends per given volume. Why is that just not gripped onto it at all? How come this one was fine? And this one's not going to grip. Let's just try another one. There we go. And then black will be white. Well, tool changer is not about filament change and tool change. It's more about printing two objects at the same time for production, rather than filament changing. Also, it does look pretty cool, so there's that. So I do want to make sure I get these, not that it really matters, but in the right places, matching the right LEDs. So let's go, where's my screwdriver, the right bit. I'm going to use some tweezers to help me get them in. So let's turn that on and see if that lights up. If it doesn't, we know we need to switch the pins. I think the LED came on before that previously, so I think it would be on right now. Check firmware. you can, well, it's much easier to print two objects at the same time on one printer than it is to print two separate objects on two separate printers in the same amount of time. Because if you can get a printer that can print twice as fast, you can just increase the speed of your IDEX as well. So you have to assume that they both print at roughly the same speed. Which again is often limited, not by the mechanics, but by the peak flow rate of your extruder hot end. Yeah, okay, so this would be on, but we're powering two separate LEDs, so it doesn't do anything. So we need to switch one of them to the other bit. Switch that negative over to there. And grab these two. So that's all those down in there. We're going to need pin data for that other heater, so we can get that here hopefully. So PA3, PB10 for our other LED. Could put them both in the same port, but I think it's a bit safer if we don't. Nothing yet. Hopefully I've not destroyed something between testing it and now. It should come on. One side is on, that's good. So you can probably see on my hand there, the top side there is on, bottom side is not. So let's sneak into the configuration. We need to basically copy and paste the LED segment we have, because I don't think you can just assign multiple pins to the same thing. So it would be nice if we could just like copy PA3 and put PB10 in there. Not sure you're allowed to do that, so we'll just copy this whole lot. And I think we can just call this case light 2 and then put this as PB10, because that was the pin if I remember correctly. So PA3 and then PB10, PA3, PB10, HE2 connector, PWM, save and restart. Now we should have both sides come on. 3, 2, 1, boom. Nope. There we go. Nice. Those lights are blinding. Oh, but it looks good. You probably can't see it very much on the live stream because of the lighting that's already added to the room. Might not be able to tell, but that looks feckin' amazing. And those baffles on the lights are just perfect. The PWM is a bit aggressive though. It looks funny, I'm waving my hand. I can see, so you know how when you watch something that's low frame rate and you can kind of see it stutter? When you move your hand in flashing lights, you can kind of see the same. So if you increase the PWM, then it won't do that. So hopefully we can change the PWM frequency. I'm guessing it's cycle time. So this is maybe in seconds, so it's 100th of a second, which is 100 Hertz, not that fast. Time in seconds for each software PWM cycle of the heater. It is not recommended to set this unless there is an electrical requirement to switch the heater faster than 10 times. Well, we're not doing heater, we're doing... does it have any recommendations? Temperatures, fans, additional, output pin, cycle time. When using hardware, cycle time is constrained by the implementation, may significantly different than 3 cycles. Well, let's just change it to 0.01 and see where we get to. 1000 Hertz, that seems maybe a little bit too much. There you go. 20 times a second, 200 times a second. $400 times a second, 400 Hertz. So you're going to give this Voron away to one of the viewers, right? No. There you go, that's much better. Now it's the same as the room lights. It doesn't look weird. At least I've convinced myself, whether that's true or not. I'm pretty sure that's true. Anyway, you probably can't notice any difference because the whole thing is at 30 frames a second anyway, or 25. It's not like you could easily ramp the print speed up 2x on one printer instead of printing ones. Not quite sure what you mean, but I mean, as a Voron prints faster than most printers by a significant margin, certainly faster than any IDEX I've seen. But there's no reason you couldn't have Voron design with IDEX. Like, the point is you can't assume that one can print faster than the other. Maybe not by a significant margin. As I said, the limit is likely to be the flow rate rather than anything else. Anyway, my voice is starting to go. Hello. That's gone weird. So, the plan was to do panels, wasn't it, next? But I didn't do the panels, I did this. So let's add these clips on here. Hopefully these work nicely. Oh yes, they're nice and tight. Better than the originals by a long shot. And they have cooled down, I think, already, so they shouldn't shrink anymore. Yeah, these are all a bit naff, these ones in here. They need stronger clips. Okery dokery. That's in, that's up, move that along. That along. That one should be in the middle. That should be symmetrical, and that is symmetrical. Cool. Man, this looks freaking good now. Right, 4¼ hours I've been doing this. Holy bananas. I don't feel like I've barely done anything still. I will do right now these belts. So I'm going to turn these. In fact, I'll leave that for panels. I think I'm going to do panels this afternoon. And then maybe, oh man, it's just going to turn into one huge long, oh, the shadows. Because there's loads of lights, there's loads of shadows of this, and they make like a, oh, anyway. This just makes really nice, even lighting. See, you can see how the baffles have that effect. Because you can see that there's light coming from them, but you don't get that glare. Oh, the guy that designed this, guy, girl, person, I don't know who it was. Well, I do. I think I shared the link. Flipping terrific idea. Yeah, if you want to know about the inductive probe, go check. I pinned a comment on the previous episode. Most of the information's there. Yeah, I think we're on to panels next, but I am hungry. I want some food, and I'm sure many of you that have been watching for a while could do with a break as well. So we're going to stop this stream, and I might do another one immediately after lunch, just so we can get things rolling and hopefully have a print live at 7 o'clock-ish this evening. Wouldn't that be fantastic? This printer is looking absolutely balling. And I should have used blue wires for the LEDs. I should have done blue and black. Oh, Adam, you fool. Oh, that would have looked so good. I bet I had the right colour as well. Never mind. It's mostly hidden. Yeah, panels hopefully starting in just an hour or so's time, providing I don't have any other commitments I've forgotten about. So thanks everyone for watching. Hopefully this has been useful for many of you watching along. Don't forget to check out the sponsors. Thank you to them, of course, for sponsoring. And we'll be back later today with some panels and maybe a first print. So I'll see you then. Ta-ra! Thank you for watching, and don't forget to leave a like. And maybe a super chat at some point. Oh, it's too late for super chats, isn't it? Anyway, thanks very much. See you all soon. Goodbye.